Evaluate the indefinite integral, and then illustrate and check your answer is reasonable by graphing both the function and its antiderivative, and then take c is equal to 0. So in this case here, we're going to go ahead and start with the u substitution. So we're going to let u of the integral of x squared sine of 2x dx. So we're going to let u equal x squared. And dv is going to equal the sine of 2x dx. And so therefore du is going to equal 2x dx and the antiderivative of the sine of 2x, okay, is negative 1/2 times the cosine of 2x. Now, if you need to check that out, just remember that if you take the antiderivative of the sine of 2x dx, we let u equal 2x, and then du is equal to 2 dx, and then divide both sides by 2. And then we would say this is the sine of u times 1/2 du. Factor out the 1/2. And then the antiderivative of the cosine of sine of u is negative cosine of u, which would be negative 1/2 cosine of u, which is 2x. Okay, so now in step number 2, let's go ahead and then use our formula. So we have x squared sine of 2x dx, which is going to equal u times v minus v du. So we have u times v, so it's going to be negative 1/2 times x squared times the cosine of 2x minus v du, which is, let's see here, we have negative 1/2 times 2x, so it's negative 1/2 times 2x times the cosine of 2x dx. So what does that give us? Well, negative times negative is going to give us a positive. And then 2 over 2 is 1, so we get x times the cosine of 2x dx. Okay, and now we're going to have to go ahead and integrate by parts again. For this. So let's go ahead and do that. So we're going to integrate that by parts. So we have x times the cosine of 2x dx. We're going to let capital U equal x, and then dv is going to equal the cosine of 2x dx. That's d capital V. We know du is going to equal dx, and we know that v is now going to equal 1/2 the sine of 2x. And so therefore we're going to get the following. We're going to get u capital V minus capital V du. So we have 1/2 x times the sine of 2x minus v du. So we have v and du, which is going to give us 1/2 times the sine of 2x dx. So now we're going to substitute this back into our original question here. So let's go ahead and do that. So we have plus 1/2 x sine of 2x minus, and then what we can do is we can factor out the 1/2. So we have 1/2, and then we're going to integrate the sine of 2x dx. Okay, so now we get negative 1/2 x squared times the cosine of 2x plus 1/2 times x times the sine of 2x minus 1/2. Well, we already know what the derivative, antiderivative of the sine of 2x dx is, which is negative 1/2 times the cosine of 2x, and then that's plus c. And so therefore we end up getting the following function: negative 1/2 x squared times the cosine of 2x plus 1/2 x times the sine of 2x plus 1/4 times the cosine of 2x plus c. And now we're going to graph this function with this function here when c is 0 on the same graph. So the lowercase f in red represents the first function, and the other graph in blue, which is the capital F, is the antiderivative. So we see from the graph that this is reasonable because you can see that f is increasing, right, where the original function is positive, and f also decreases where capital F decreases when lowercase f is negative. And also note that f is an odd function. The first function, lowercase f, is an odd function, and capital F is an even function.